Have you ever wondered what it would be like to see a mountain explode? That's exactly what a volcano is. It's one of nature's biggest, loudest, and most amazing shows. These aren't just any old mountains. They are gateways to the center of our planet. They can sleep for hundreds or even thousands of years, but when they wake up, they can change the world in an instant. Imagine a fireworks display so powerful it shakes the ground, fills the sky with ash, sends rivers of melted rock flowing for miles. This is the incredible force of a volcano, a raw display of the Earth's inner power. It's a fiery reminder that our planet is alive, constantly changing and full of secrets deep beneath our feet. Volcanoes have captured our imagination for centuries. Ancient civilizations told stories about gods living inside these smoking mountains, controlling their fiery tempers. Today, scientists study them to understand what's happening deep inside the Earth. They are like giant science experiments showing us the ingredients that built our world. The energy released during a single eruption can be more powerful than dozens of atomic bombs. It's a force that can build islands from the bottom of the sea or bury entire cities under a thick blanket of ash. This awesome power is both terrifying and fascinating, a spectacle of nature's ability to create and destroy. Think about it. Deep below where you're standing right now, the inside of our planet is a super hot, gooey place. It's not solid like the ground we walk on. Molten rock, intense heat, crushing pressure. Volcanoes are like safety valves for the planet. They let out some of that intense heat and pressure from deep within the Earth's core. Without them, who knows what might happen. These fiery mountains are a crucial part of how our planet works, shaping continents and creating new land for billions of years. They are the Earth's heartbeat, pulsing with incredible energy. So get ready for an explosive journey. We are going to peel back the layers of a volcano. We'll dive into a chamber of bubbling, molten rock. We will watch as pressure builds and builds, like shaking up a soda can. And then we'll witness the moment the volcano can't hold it in any longer. We will explore the science behind the sizzle, the bang, and the incredible flow of lava. Let's shrink down and take a look inside one of these incredible mountains. If we could slice a volcano in half like a giant cake, what would we see? It's not just a big pile of dirt and rock. It's a complex system of pipes and chambers, all leading from deep within the Earth to the surface. At the very bottom, miles beneath the ground, is the heart of the volcano, the magma chamber. This is a huge underground pool filled with magma, which is the name for molten rock when it's still underground. Think of it as the volcano's fuel tank, a sizzling, bubbling cavern of super hot liquid rock, just waiting for its moment to escape. Where does all this magma come from? It doesn't just appear out of nowhere, it's cooked up deep inside the Earth in a layer called the mantle. The mantle is mostly solid rock under extreme heat and pressure. Think of it like a block of very, very hard caramel. It's solid, but so hot it can slowly move and ooze over millions of years. In certain spots, the rock can actually melt. This happens where tectonic plates are pulling apart or where they're crashing into each other. That melted rock is magma. Magma is a hot liquid and less dense than solid rock. Less dense stuff in a denser fluid rises. It floats. A cork floats in water. A hot air balloon rises into the air. Likewise, a blob of magma slowly rises toward the surface. It pushes up through cracks and weaknesses in the crust. The journey is very slow, thousands of years. As it rises, it melts more rock and grows larger as it ascends. Eventually, it pools and forms a magma chamber. Magma chambers sit a few miles beneath the surface. It's like a giant underground waiting room or a kitchen where the eruption recipe is prepared. Now we have a magma chamber full of super hot, gassy, molten rock. What happens next is all about one simple word: pressure. Imagine you have a can of soda. The fizzy bubbles in the soda are made of carbon dioxide gas that has been dissolved into the liquid under high pressure. As long as the can is sealed, the pressure keeps the gas inside the liquid, and everything is calm. The magma chamber is just like that can of soda, but on a much, much bigger and hotter scale. The immense weight of the miles of rock sitting on top of the chamber creates enormous pressure, keeping most of the dissolved gases trapped inside the liquid magma. But things are changing. More and more magma might be pushing into the chamber from below, trying to squeeze into a space that's already full. This is like pumping more and more air into a tire. The pressure inside starts to build. As the pressure increases, the rock around the magma chamber starts to strain. It might crack and shift. Scientists can actually detect this. They use sensitive instruments to measure tiny earthquakes called tremors, and to see the ground on the surface of the volcano start to swell up, like a balloon being inflated. The mountain is literally getting bigger as the chamber below fills up. As the magma churns and stews, another process is happening. The dissolved gases, mostly water vapor, carbon dioxide, and sulfur dioxide, are starting to come out of the liquid rock and form bubbles. This process is called exsolution. It's the exact same thing that happens when you open your can of soda. The moment you pop the top, the pressure is released and all those dissolved gases rush to form bubbles. In the magma chamber, as it gets more crowded and the magma moves around, these bubbles start to form and grow. This makes the magma even lighter and more buoyant, wanting to rise even faster. These gas bubbles are the key to an explosive eruption. They take up way more space than the dissolved gas did. A little bit of gas can create a huge bubble. As more and more bubbles form, they dramatically increase the pressure inside the magma chamber. It's a runaway process. The pressure is now at a critical level. The magma chamber is stretched to its limit. The frothy, gas-filled magma is violently pushing against its rocky ceiling. It's like holding your thumb over the top of a garden hose with the water turned on full blast. The pressure is just too much. All it takes is one final trigger. This trigger is often a crack. The intense pressure from the magma can fracture the rock above it, creating a pathway for escape. This crack acts like a release valve, and it's the beginning of the end. Once that first crack forms, the effect is instantaneous and catastrophic. The pressure at the top of the magma chamber suddenly drops. This causes a chain reaction. Remember the soda can? This is the moment you pop the tab. With the pressure suddenly lowered, all the gases still dissolved in the magma instantly and violently flash into bubbles. It's a process called rapid decompression. The magma, which was a thick liquid just a moment before, turns into a raging foam of gas and rock, expanding to hundreds of times its original volume in a fraction of a second. This explosive expansion is the engine of the eruption. This expanding frothy magma has nowhere to go but up. It hurtles through the main conduit at incredible speeds, sometimes faster than the speed of sound. As it rips its way toward the surface, it tears apart the rock walls of the conduit, adding even more debris to the explosive mixture. The ground shakes violently. A deep, deafening roar echoes from within the mountain, a sound so low you feel it in your bones more than you hear it with your ears. On the surface, steam and gas may start to jet out of small cracks or fumaroles, a final warning that the main event is just seconds away. Kaboom! This is the moment. Top of the mountain blows apart in a cataclysmic explosion. A colossal column of ash rockets into the sky. Dark, churning mushroom cloud climbs toward the edge of space. The eruption column. The sheer force of the blast creates a shockwave that flattens forests and anything else in its path. This creates a pyroclastic flow. It's a superheated, fast-moving avalanche of gas, ash, and rock fragments that screams down the sides of the volcano at speeds of over 100 miles per hour. At the same time, liquid fire begins to pour from the crater. Huge fountains of glowing red and orange lava can shoot hundreds of feet into the air. Boulders of semi-molten rock called volcanic bombs are flung for miles, crashing to the ground with explosive force. After the incredible fury of the main eruption, the volcano slowly begins to calm down. The explosive blast may stop, the towering ash column may shrink and fade away, but the show isn't over yet. Lava flows, glowing rivers of molten rock, push across the land. They continue their slow, relentless march. They can flow for days, weeks, or even months after the eruption ends. As the lava moves, it begins to cool. The outer surface hardens into a black, crusty shell. Inside, a molten river still runs. Cracks sometimes reveal a glowing red interior. When the lava finally stops and cools, it hardens into new rock. This new rock is igneous. The landscape is completely transformed. Valleys once green are now seas of jagged black rock. Entire forests lie buried under the flow. The world looks alien and barren. Ash has coated everything in a thick gray blanket, silencing nature. It feels like total destruction. The volcano itself has changed. The crater may be much larger now, or it may have collapsed into a caldera. The mountain sides are scarred by pyroclastic paths. New layers of lava blanket slopes. Ash covers ridgelines. The mountain may be shorter, its top blown off. The area is proof of immense power unleashed. A world remade by fire. A reminder of Earth's fast-changing face. It might be hard to believe, but the destructive power of a volcano is also a powerful force for creation. The ash that blanketed the landscape, which seemed so deadly at first, is actually packed with rich minerals and nutrients. Once rain washes this ash into the ground, it creates incredibly fertile soil. Over time, this volcanic soil becomes some of the best farmland in the world. The new rock formed by the cooled lava flows also becomes a foundation for new life. At first, the landscape is barren and black, but soon hardy pioneer species like lichens mosses begin to grow on the rock surfaces. As they grow and die, they break down the rock and create the first tiny pockets of soil. This allows small plants ferns to take root. Slowly but surely, life begins to reclaim the land. It's a slow process, but it shows the incredible resilience of nature. What was once a field of sterile rock will one day be a thriving forest again. Volcanoes are also Earth's master builders. The Hawaiian Islands, for example, would not exist without them. They were built from the ground up by countless eruptions on the seafloor over millions of years. Every time a volcano erupts, it can add new land to our planet. Lava flowing into the ocean cools and hardens, extending coastlines, creating new territory. On a much larger scale, volcanic activity over billions of years has been responsible for creating much of the land we live on, and even the air we breathe. The gases released from volcanoes helped form Earth's early atmosphere and oceans. So, while an eruption is a terrifying event up close, it's a necessary part of how our planet works. It's a cycle of destruction and renewal. The volcano takes away, but it also gives back in abundance.